and you answered the last two questions on your own correctly, you got a 10 out of 10. If you missed anything, you left off a unit somewhere, you didn't show all the steps in the guess method that I was showing you, you lost points. Or you didn't answer questions correctly. Okay. Very good. Okay, one per page. Thank you. Good. Thank you. Thank you. Try to make this thing 2/3 of the sheet. This is what you're reading. Thank you. You don't need a Chromebook, so you can put that away. The quiz is not on your Chromebook. It's on paper. You can't make. I'm not quizzing you on how to make a graph electronically. I'm quizzing you on how to make a graph by hand. Hence, that's why you need a pencil and a ruler right now. Okay? So let's check the 3 graphs that you made before I give you another one to make for me on paper. All right, the first graph was the graph that had volume and pressure on it. So let's check that you have the correct title on this graph. The graph should be labeled volume versus pressure as the title. If you're missing the title, add it. You need that title. If you reversed the variables, that's wrong. Please fix it. It had to be volume versus pressure, not pressure versus volume. On the y-axis, you should have put the label volume in mLs. On the horizontal axis, you should have put the label pressure in torr. Now, let's look at what it looks like. Oh, if I can get it to show the whole darn thing, I'm not sure I can. Okay, so when I grade your graph, I'm going to be checking that every line on the horizontal axis has the same incremental value. Based on the graph paper I had, I chose every line on the horizontal was 100 torr. So I labeled every other line, so 0, 200, 400, 600, 800, all the way up. You should be going beyond the highest value that you were provided in the table. That's the smallest, highest value, but you should try to go beyond at least a little bit. That's why I was able to get up to 1400 on this scale. On the vertical axis, again, I'm checking for the same incremental value. I went from 0 to 900, and every line was 100 mLs. That's what worked for the graph paper I had. Yours may be different. I have to check yours individually to see if that works. But then I am going to check that all your data points are placed in the correct locations. 1, 2, 3, 4, 5, 6, 7 of them. So I should clearly see 7 data points. And then I should see a nice smooth curve as best as you could free-handed to look like that. All right, any questions on the first graph? Okay, and I will be checking that you are plotting every point correctly. 1 point incorrectly plotted loses you a point. All right, the next graph, the title should be distance versus time. So let's make sure that is the title you have on your second graph, distance versus time, not time versus distance. We need distance in meters on the vertical axis. We should have labeled time in seconds on the horizontal axis. And then, again, I'm looking for uniform scaling on the x-axis and uniform scaling on the y-axis. Exactly what that scaling is depends on how many grids you have and so forth. Then I'm going to be checking all your data points. There should be 1, 2, 3, 4, 5, 6 of them. And then a nice smooth curve that goes up like that. Any questions on graph 2? Yep. Does it have to hit every point? No. It's best fit. So you want to try to hit as many points as possible. But honestly, if you hit every point here, it's not going to be smooth. You're going to have little bumps in the curve, which is not what we want. Yep.
Do we have to put X's on the pad?
X's, dots, or little dots with circles around them, or pluses. Remember, I gave you those options yesterday, the types of markers you can use. I choose to use X's when I do it. I think it's a little easier to see. Anything else? Yep.
So on the last graph, I did
Graph 1?
Yeah, graph 1. So I slightly missed the point. It was above the line.
Yep.
It was above the line. Another point was below the line.
That's fine.
But I was still kind of able to hit the last point. So I still leave it as it is.
That's fine. Yeah.
Okay.
Yeah, I just don't want to see bumps like that. It should be smooth, showing one trend.
Okay.
Okay.
I just want the one part.
On this one?
Yeah, just in general, do I put both zeros and I put one in the corner?
You should have a 0 on the Y and a 0 on the X. Yeah, you're welcome. Otherwise, when you just put a single one, some people think it means origin. Others, it's not clear. So you want to make sure you put both zeros. Okay. Just to be precise about it. Okay, let's look at the third and final graph. The title on this graph should be speed versus time, not time versus speed, speed versus time. Then on the vertical axis, you should have the label speed in meters per second. On the horizontal axis, you should have the label time in seconds. Again, I'm going to be looking at the scaling on both axes. What your scaling is depends on how many lines you have, but every line should have the same incremental value on the x-axis and then on the y. Now let's check how many data points you have. You should have 1, 2, 3, 4, 5, 6. And this should be a nice diagonal line drawn with a ruler, not free-handed. And it should be best fit, which means you're going to have a couple of points that don't lie on the line if it's truly best fit. There was no way to get a line that hit every single point on this graph. It wasn't a perfect, you don't have perfect data. Okay, data is never perfect. You should never be getting a line that hits every single point in the real world. Sometimes when I make up a question, things will be perfect, but then you know it's all made up. Okay. Any questions on this? All right, you ready to make one on your own now? Okay, let me shift over, put this back up. You can keep those graphs out to help you. Let me give you one graph to do. You do not need graph paper. I'm providing it to you. You just need your pencil and your ruler. No pen. Absolutely no pen. You're welcome. You're welcome. And again, you can use those graphs to help you. You're welcome. To make sure that you're doing things correctly, labeling everything that needs to be labeled. And when you are done with your graph, I would like you to raise your hand so I can come and collect it from you, okay? You're welcome. When you finish the quiz, raise your hand. I'll come get your quiz from you, and then you can take the items out that are up on the board. Thank you. Thank you. It's not really straight, but you should have a ruler. No, no, just not have a. It's pointless for you. Okay, I'll give you 1 more minute to wrap up the graph. 1 more minute. Should not be talking. People are still taking the quiz. Thank you. All right. Do I have everybody's quiz? Are you working or?
Yeah, let's put my graph in that.
Okay. Try to finish it up. The rest of you, could you please make sure that you've got out your pencil, your notebook, your calculator, your reference table, and your Unit 1 packet. We're going to finish Unit 1 today. First unit of 16 for the physics course will be done with content at the end of today's class. Tomorrow will be your last quiz for Unit 1. And we're going to be learning now that we know how to make a graph. We're going to learn how to read them and interpret them and figure out what the data is trying to communicate to us. Look, what patterns do we see when we look at these graphs? That's what we're really going to try to figure out. Tonight's homework is to finish any problems on pages 17 through 19 in your packet that I don't get through with you in class today. All right, 17, 18, and 19. Whatever I don't finish with you in class is your assignment for tomorrow. And then you'll be able to use that homework on tomorrow's quiz when we are interpreting graphs. Okay. Let's shift over then to my notes on this and we'll go through it. Interpreting graphs. I don't need publisher. There we go. All right, let's talk about interpreting graphs, section H of Unit 1. So what I'll ask you to do on tomorrow's quiz are the following things. I'm going to ask you first to name the shape of a graph that we're looking at. This is basically the flashcard stuff. Put a picture of the graph on the front, and you should be able to just name the shape, one word. Okay? Name the shape. And the shapes are very specific. Then I'll ask you to tell me what the relationship is between the variables on that graph. Again, this is flashcard stuff. It's like one-word answers. What's the shape? And then what's the relationship? And they are not interchangeable. Okay, they're separate questions. Then if the graph happens to be linear, we're going to ask you to determine or calculate the following things for that line graph. I'll ask you to determine what the y-intercept is for the graph. I'll ask you to calculate the slope of the graph and then write the equation for that line using the variables that are on the graph and the slope and the y-intercept that you just determined or calculated. Okay, and I'm going to show you how to do that and what we expect you to show. All right, so here are the different shapes that we have for graphs. So why don't we go ahead and draw those pictures first? You don't need to put the variable names on the graphs. Just go ahead, sketch the x and y axes, and then go ahead and put the different graphs that you see. And then we'll go through and name the shapes of each of them, okay? So there's 5 different graphs that I asked you to draw. Let's go through what they are. You ready? So you can label them. It says there are 4 shapes here. There are 4, even though there are 5 graphs. 2 of them have the same shape. The first is the horizontal line. Can you identify which graph there is the horizontal line? Which of those 5 pictured is the horizontal line? Ryder? Which one's the first one? Top left, that's it. So you may want to label this graph horizontal line. That is a horizontal line. Okay. The next shape is the diagonal line. Which of those graphs is a diagonal line?
Top right.
That's right, top right. Go ahead and label this graph diagonal line, please. Diagonal line. Diagonal line. That's this one here. All right, the third shape is called a parabola. There are actually 2 of them here, which are parabolas. Anybody know which 2 they are? One?
Bottom 2 on the right.
Yeah, left. It's actually these 2. These 2 here are parabolas. They are each half of a U. They're each half of a U. This one is what we call a concave down, the left half of a concave down parabola. And this one is the right half of a concave up parabola, meaning it opens up. This one would open down if I continue the U. So these 2 here are parabolas. So please label both of these parabolas. The last shape, which is this graph here, is a hyperbola. 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 Now let me explain how you can determine whether it's a parabola or a hyperbola, because they're all curves. We don't say that the shape is a curve. You either have to tell me that it's a parabola or a hyperbola if it's curved. Which type of curve is it? With a parabola, you will always see that the curve intersects one of the 2 axes. This parabola is going through the x-axis here. This parabola will go through the y-axis here. As opposed to the hyperbola, which is asymptotic towards both axes. It approaches each axis, but it will never cross it. Never, ever. So another way to kind of sketch that hyperbola is so it looks something like this. You see how it looks like each side of the curve is going to go towards the axis, but it never actually hits it. It will get really close, but not hit it. Same thing here. It's getting closer and closer and closer, but it will never intersect the axis. That's a hyperbola. Okay, good with that? That tackles the first objective. You need to be able to identify those four shapes for me. Or if I give you the one, you can say, oh, that's a horizontal line. Or Miss Famoso, that's a parabola. Or this is a hyperbola. That kind of thing. All right, now let's go to the relationships. There are 5 basic relationships. When you have a diagonal line like this that has a positive slope, we say that that is a direct relationship. So the clue to it being a direct relationship is that not only is it a diagonal line, but it has what we call a positive slope, meaning the graph is going up. Okay, that's a direct relationship. Now, you do need to know the general equation for a direct relationship graph. That equation is y equals mx plus b, but the m value, which stands for the slope, is positive. The fact that we have a positive slope on this diagonal line is what makes it a direct relationship. So if I asked you, is that graph shape direct? What would you say? Is the shape direct? No. What's direct? The relationship, okay? What is the shape? Diagonal line. Don't just say diagonal. It's a diagonal what? A diagonal line, 2 words. Okay, the next relationship we have is for another type of diagonal line. This one has a slope that's coming down. It's a negative slope. So if you have a negatively sloped diagonal line, we call that an indirect relationship. Notice that the general equation looks a lot like the one we saw for the direct relationship, but the slope is now negative. So if you have a negative sloped diagonal line, then it's an indirect relationship. I can tell you, you will never see those in this class. Never. I'm showing it just to be complete, but we don't have those. Okay, ready for the third one? The third one is for the horizontal line. If you have a horizontal line, the slope of this line is 0, which means that as one variable, the horizontal variable on the x-axis is increasing, the variable on the y-axis stays the same. That's what we mean by a constant relationship. Since the slope of that line is 0, the mx term would drop out of the equation, leaving us with just an equation y equals b, where b is the y-intercept. All right, the fourth relationship goes with our parabolas. Every parabola has what we call a quadratic relationship. Have you heard of the quadratic equation before from math class? Quadratics have a squared term. Either the y term is squared or the x term is squared, which leads us to creating that parabola on our graphs. So when we have a parabola, we say the relationship is quadratic. And if it is formed with the x term being squared, the general equation would be y equals kx squared, and then we would see a parabola that goes up like that. If the y term is being squared, we get the other parabola I showed you, the one that goes up and levels off. Okay. But both of those parabolas have a quadratic relationship, either formed by the x term being squared or the y term being squared. All right, there's only one more relationship. You ready for that? The final relationship is called an inverse relationship. The inverse relationship always occurs when we have a hyperbola. So whenever we see a hyperbola on our graph, that is an inverse relationship. And the general equation for a hyperbola is y equals k over x. Y is k over x. Okay, are we all set with that? All right, then let's talk about those line graphs, because I said if you have a line graph, you have to be able to do three other things. The first thing you have to do for a line graph is be able to determine the y-intercept. The y-intercept is symbolized in mathematics with a lowercase b. I think you know that, y equals mx plus b. The b stands for the y-intercept of the graph. Now, what is a y-intercept? The y-intercept is the y coordinate when the x coordinate is 0. So when x equals 0, what does y equal? That's what we're asking you for. When you look at a graph that's a line, all you do is go on your graph, find the x coordinate of 0, and then go up or down on the y-axis and read off the y coordinate. That is your y-intercept. So on a graph like this y coordinate right here, here's my x of 0. I go up and I read the value right there. We don't say that the y-intercept is 0, comma, I don't know, let's say that number was 5 right there. We wouldn't say 0, comma 5. We would just say that the y-intercept is 5. And then we would add the units that we have on the y-axis to it, like meters, 5 meters, or 5 seconds, or 5 meters per second, or whatever was on the y-axis. So this you just read off the graph. Okay. Everybody all set? Yes? Okay. Let's then talk about the slope. The slope is symbolized in our equation for a line with a lowercase m. Lowercase m stands for slope. Now, you will need to know what the slope formula is. It is not given to you on your reference table. It's one that you need to have memorized. Most of us, I think, already have it memorized from math class, but the way we find the slope of a line is by looking at the change in the y variable over the change in the x variable between 2 points on the line. Or another way to say that is rise over run, or we can write it like this, where y2 stands for the y coordinate of a second point on the line. y1 is the y coordinate of the first point on our line. x2 is the x coordinate of the second point on the line. And x1 is the x coordinate of the first point on our line. Now, because I know that it may have been a little while since you've calculated slopes, I've told you to take out your reference table. We're going to add this equation to our reference table before we do anything else. So let's go to the end of your reference table. You have a blank page. This would be page 7 if we were to number it. And we're going to add equations that are not here that we need for the course. This equation for unit 1 that we need is our slope equation. So I'm going to say that the slope is equal to y2 minus y1 over x2 minus x1. That's the equation that we're going to use for the slope. Slope is y2 minus y1 over x2 minus x1. There was one other equation that you'll need to have memorized for your test in this unit, and that is your percent error equation. It was absolute value of accepted minus measured all over accepted times 100%. That's how you get your percent error. So those are the two equations you'll need to have memorized for this unit. We're just adding them to page 7 of our reference table now. You'll need to have those both memorized by the time you take your first test next Wednesday, a week from today. Okay? Can I go on? All right, so back to our line graph. So when we do this, the one thing you have to make sure, this is different from math class. In math class, you have lines and every point they give you is on your line. In a science course, that's not going to be true. The data points may not be on the line. You're going to be asked to calculate the slope of the line, not the slope of the data points. So it is extremely important that the points you're plugging in happen to be on the line. If you plug in a data point that was off of the line that you drew, you didn't find the slope of the line. So generally when we do this, we're going to ignore the data table. We're going to look for 2 points that actually reside on the line and use those coordinates to calculate the slope. Okay, you understand the difference, what I mean? It's really important that you're using points that are on the line, not off the line. So ignore the data points, ignore the data table, I should say. The other thing in our class, you must calculate this out as a decimal with sig figs. Do not leave your slope answers as fractions. Maybe you want to make a note of that. Calculate it out, divide it, get an answer with sig figs. That's a decimal. If you leave it as a fraction, it's going to be marked wrong. You hear that? You leave it as a fraction, and what do I have to do? Mark it wrong because there's no sig figs on a fraction. You need significant figures on these answers along with units, and we'll talk about how to do that with our first example in a minute. All right, can I go to the last slide? The last thing we have to do for a line graph is be able to write the general or write the equation for the graph in front of us. As you know from your math courses, the general equation for every line is y equals mx plus b. So when I give you a line graph, you can start with that, but then you have to make it specific to the graph that is in front of you. We change everything out. You won't have a y, an m, an x, or a b in your final equation. Here's what I mean. Change out the letter y to the name of the actual variable or the symbol for the variable that's on the y-axis. So you know how we made one graph that was a speed time graph for homework? What was on the y-axis was speed. So I would change the letter y to speed. I would say speed equals. So now you're telling me that speed was on the y-axis of your graph. Then you're going to change out the letter x to the name of the actual variable that was put on your x-axis. So in that speed time graph, I would change the letter x to the word time. Then, since you will have now calculated the slope with units and significant figures, you're going to change out the letter m and actually plug in the slope that you calculated. And then finally, I want you to change out the letter b and put in the actual y-intercept value with the unit. So that way we know where the graph starts. Where does the line begin on your graph? At what point? Once you've done that, now you have an equation that is specific to the graph in front of you, which is we know exactly what was on each axis, we know where the line starts, and we know how steep to draw the line from there. All right, that is the end of my presentation. So what I would like us to do now is to go to page 17. And we're going to try to work through at least problem 1. So that way you have an idea of how to do this with the other 2 pages for homework tonight. What I'm going to do is not really ask you anything. I'm just going to do it and model what I expect to see for your answers and your solutions to this. So that way tomorrow when you're taking a quiz and have this in front of you, you can use the homework to help you. Okay? Can I switch over to my document camera? Everybody good?
Page 17.
Page 17, please. Yep. We'll get started on these practice questions on interpreting graphs now. Can I go to the document camera? Okay. All right. So number 1 on page 17 gives us this graph of position versus time. So the first question is, which variable is the independent variable? We learned this the other day. Independent variable is the x or the y? X. So that means it is time. Which variable is the dependent one then? Position, because it's on the y-axis. All right, now what's the shape of this graph? Diagonal line. It is a diagonal line. 2 words. What is this relationship? It is direct because it is a positively sloped diagonal line. Okay, now we have to get to the fun part. Can we calculate the slope of this? We're going to use our guess method. We're going to find 2 points on this line that are right on the line. I'm going to use this point here. I'm going to call that point 1. Notice I'm circling and labeling it 1. And I'm going to use this point here as 0.2. Those are both right on my line. So now what I'm going to do is list the coordinates of 0.1 and 0.2 in XY coordinate form. 0.1 has an X coordinate of 0 seconds. Do you see think of this as like a column heading. I'm telling you that these are measured in seconds. Every number here is in seconds. So the X coordinate is 0 seconds. The Y coordinate would be at 100 meters. Are you with me? Notice I put units after each number. We're going to do the same thing for 0.2. The X coordinate of 0.2 is 5 seconds. The Y coordinate is 1,400 meters. Now, what is the unknown? It is the slope. What is our equation for the slope? We just wrote it on our reference table. That slope is y2 minus y1 all over x2 minus x1. Now I'm going to do my substitution with the units. So the second y coordinate is 1,400 meters. My first y coordinate is 100 meters. My second x coordinate was 5 seconds. My first x coordinate was 0 seconds. Now I'm going to work that out on the side doing sig figs. 1,400 minus 100, I pay attention to precision. That would be positive 1,300 meters. The denominator would give me 5 seconds. Notice that 5 seconds has only one significant figure. So I'm going to write my answer with only one significant figure after I divide that out. 1,300 divided by 5 is 260. If I round that to one significant figure, what do I get? Round it to one sig fig, what is it? 300, positive 300. So our final answer for the slope is positive 300 m over s. All right, I'll pick up with more of this with you tomorrow. We'll go over the whole thing, make sure you're comfortable with it, and then we'll take a quiz on it, okay? Have a great day, folks, and I'll see you tomorrow.